Today, Dr. Amjad will be talking about biotechnology for organic. Time to define the term. With this brief introduction, please welcome Dr. Amjad Masood Hussaini. Over to you, sir.
Hello. Am I audible?
Yes, sir, you're audible. You're audible.
Okay, thank you. First of all, I would like to thank the organizing committee, uh, uh, Dr. Javed and Dr. Suhaib and others to have invited me on this platform to share the views which I support and to deliver the lecture in this web conference. So I am trying to share, I think I have shared the PPT. Is it visible to you or?
No, sir, your PPT is not visible.
It is not visible, okay.
No.
I'll do it again.
Now it's visible.
Okay, great. So, first of all, to put things in perspective, I think some of our speakers earlier have already delved upon many aspects of sustainable agriculture and the role of the transgenics, biotechnology, and also in organic, organic agriculture, especially the plenary lecture by Dr. Delfouza delved deep on some of the aspects of organic agriculture. And to take it further, what I wish to discuss here in this presentation is that can we have a new kind of a definition of the dogmatic aspects wherein we have put our stance on, and can we make some modifications in light of the many new challenges which have cropped up in the current century, which were not there in earlier. So why is it not going to the next? So sorry about this. I am trying to see the things easily. Yeah. So our challenge as agricultural scientists, most of the talks which we listen in the pre-afternoon session were regarding sustainable environment, sustainable agriculture, and that is what actually is a concern. And here, if you see, as agricultural scientists, if we put things in perspective, if you see in the prior to industrial revolution, the global population was around 1 billion only, and so there were ample resources for us in terms of the land availability, and they were not the issues with respect to the climate change taking place, the new challenges, the growing population. It was not there. By 19th century, the population increased to 1.6 billion. And as you know, Dr. Norman Borlaug, he was a breeder, and he bred many of the varieties in wheat in Mexico, which led to a revolution, which was later called as the Green Revolution. And it was the breeding technologies which harnessed that green revolution, and along with the potential of having higher yields, they were responsive to agricultural chemicals, chemical-based inputs. And at that time, the main concern was to feed the population. So increasing the food availability was the main concern, and it was not thought that this kind of chemical-based agriculture can lead to the sustainability issues later on. So by the turn of this next century, that is the 21st century, now we see that the current population is around 7.6 billion plus, and if you see, we have to now increase the production of food, and with minimum resources. The resources are shrinking, and the challenges are expanding. So how do we do that? What are the next steps we can take? Herein, if you see, the transgenics and the biotech crops come into the context, and they were actually the advanced breeding technologies, more precise technologies, which helped the scientists to maneuver, to manipulate the genetic makeup in the organisms, so that they are able to have better productivity, more insect resistance, disease resistance, better nitrogen use efficiency, and also forth, many other traits. So with all these techniques, there came up the problems. The problems were mostly because of unknown danger of this technology. In this talk, I would try to delve on the organic aspects, organic agriculture, and the transgenic agriculture. And so if you see, the 21st century challenges are different. These are not the same challenges which humanity faced earlier. So we need more resilient food production systems. If you see, in June 2008, FOA, together with other organizations, CGAIR, they convened a conference on world food security. And that, it was attended by 181 countries and adopted a resolution. The resolution was, it is essential to address the question of how to increase the resilience of food production systems to challenges posed by climate change. So climate change has not been an easy thing to tackle. There are several aspects to it. One is that what causes climate change and how to mitigate those effects. And another is how to build a resilient food security system, which is able to survive despite of such challenges. This is a review article, perspective article, the biotech crops imperative for achieving Millennium Development Goals and Sustainability of Agriculture in the Climate Change Era, which I had authored with Dr. Narinder Tuteja from International Center for Genetic Engineering and Biotechnology. And it gives some of the aspects related to this kind of problem. So is it time to reinvent agriculture? If you see now, the agriculture is facing, as I discussed, the challenges of climate. The global climate, the regional climate, the latitudinal and the local microclimates are changing. Global warming has caused many aspects which were hither to unknown to humanity, and the agricultural systems were not prepared for such exigencies. Uh, Now, these effects remain here. The cold shock problems, the heat issues, the heat stress, the drought stress, elevation in carbon dioxide, all these stresses remain. So, can we continue with the earlier aspect? Can we continue with the chemical-based conventional agriculture? Or shall we continue with the organic farming systems? So are the principles behind organic farming uniform across the world? If they are not uniform, can we adopt certain changes which the growing human population and the climate change effects get addressed through? So now, what are the resources available to us? The resources which are available to all of us are biodiversity. You have to first, if you address a challenge, you have to know that what are the things which can be of use to us. So in that, we have to look at the holistic aspect of it. As the previous speakers have said, environmental sustainability, food security. There is a Kashmiri saying by a Sufi saint, "An poshitele yeli van posh." And if that is translated, I've translated that into food security is subservient to environmental sustainability. So it is particularly because the forests are occupy a very important aspect in the environment. So the saint says it particularly to the forests, but it is actually in the context of the whole environment, environmental sustainability. So what are the resources we have? We have biodiversity, we have water, we have now the gene banks. From this biodiversity, we got the genes, which can be of use to us. Then we have the seeds, if they are seed producing plants. And all this leads to food bank, which is to feed our growing population, to feed the population which is marginalized, which is poor, which who don't have access to costly foods. And then if you see the goals, one of my previous speakers talked about sustainable goals. She talked about the Millennium Development Goal of addressing poverty and reducing hunger. So if you see here in the Millennium Development Goals as well as in the Sustainable Development Goals, there is a common thing, and that common thing is around agriculture and poverty and energy. How to address these problems. These problems still remain there, and development and climate are inextricably linked. So we cannot say that, okay, we will go on for development in terms of building infrastructure, industries and all, and then we cannot call that sustainable. That I will come, and here this growth and development, which is based on gross domestic product, was considered to be incomplete definition of development. So there was a commission being set up by the French president, and this was formed of the members. Joseph and was the chair. Amrita Sen was the economic advisor, and Jean Paul was the coordinator. If you see here, if you see here, they say that this kind of wealth and social progress of a nation could be measured without relying on the unidirectional gross domestic product measure. So they negate this aspect and edit much more to it. So the commission identified 8 dimensions that make up overall well-being. And that is the economic well-being. That is only one part of it. Then there is health, education, work, political voice, personal relationships, environment, and security. So as Dr. Band in his opening remarks said that, we owe these resources to our future generations. It is important, if we have to take sustainability into account, that we address the problems right now, so that what we owe to the future generations, we pass on to them. So what do we need to do? The challenges before us are to make agriculture remunerative, a vocation, on a sustainable basis. If you see, most of the youth are now not attracted to agriculture. It is because something that it is more of the drudgery which is involved, and there are aspects to it, the challenges which make it unattractive. And the growth of the services sector has changed, the perspective among the youth, and they try to move more towards the services sector. So how to make this agriculture a remunerative vocation? It is a challenge. Then the agriculture, increase agricultural production in a sustainable manner to ensure food and nutritional security. Already I have discussed. Provide income and livelihood security to the farmers. Farmers are the base of the whole society. We have, unless and until we address their livelihood security issues, we won't progress. We cannot have a large chunk of population with a begging bowl and then expect that the society is going to progress. So we have to ensure a livelihood security to our farmers. Then increase agricultural production despite limited natural resources. The resources are shrinking. So what options do we have? The options generally which we think we have are conventional high input agriculture. This, as you know, the input is in terms of chemical input. Input is in terms of machine agriculture, automation, and high yielding seeds, high yielding varieties, which are responsive to all these chemical based inputs. Other extreme is the organic farming. Organic farming proponents say that it is an age-old phenomenon which is sustainable, which has been going on throughout these centuries, and so it is a viable option, which is according to them healthy also. So is there another option too? Do we have some other option besides these two options? And if we have, do we need to redefine the terms of the agriculture, the terms on which these two options have been defined? Yes, we do. First, let's see a little bit about what is organic farming. If you see, the International Federation of Organic Agricultural Movements in 2005 gave a definition, which is organic agriculture is a production system that sustains the health of soils, ecosystems, and people. So it is a holistic way of looking. It takes care of the health of the soils as well as ecosystems and people, which is really a great thing to do. Then, if you see the 1998 declaration, Mar del Plata Declaration, it's called, and they exclude the use of GMOs in food production and agriculture. The argument behind this declaration, just go through it. It involves unacceptable threats to human health, negative and irreversible environmental impacts, the release of organisms of an unrecallable nature, the removal of the right of choice, both for farmers and consumers, violation of farmers' fundamental property rights, and endangerment of their economic independence. Practices which are incompatible with the principles of sustainable agriculture. So if you concentrate here, there are certain aspects which are related to human health and environmental aspects. The rest of them are mostly dependent on the social aspects of it. That is the right of choice, the farmers, consumers, the violation of the farmers' fundamental property rights, the patent, the terminator technology, all that thing actually address it in the second half of the argument against GMOs. We must remember that this declaration is in 1998, which is more than 20 years ago. So we need to revisit it. Are these threats really so now in light of the new developments? They were pertinent. The concerns raised were pertinent at that point in time. But do they stand the test of time? So then if we go towards what biotechnology is, if we think of biotechnology, it is simply the use of technology to improve a biological organism. And it is actually more precise. It is precision agriculture. It is interdisciplinary in nature. It uses biochemistry, microbiology, engineering sciences, etc., and uses cells, tissues, and parts, and all the genetic makeup of the organisms. But the concern is the human welfare. In both these, it is the sustainability and the human welfare which is the concern. The approaches may be different. So I think this is an artificial dichotomy with respect to the targets. Will it stand the test of time? So I already discussed that should we revisit the 2-decade-old IFOAM declaration in light of the more recent findings? There are fears, and the GM crops supposedly are harmful, but there are so many reports by eminent scientific bodies which dispel those fears. The EU regulations have exceptions to the prohibition of GM crops in organic agriculture. If you see the GM crops, the EU regulations, they have some of the exceptions to them. They allow these in organic agriculture, especially in the veterinary medicine, feed and food additives derived from GM crops, especially when there are no GM-free alternatives available. So how can GM crops help? The GM crops can help in addressing all these issues which are of the 21st century challenges. The challenges of the climate change, the heat stress, the drought stress, the water logging, the salinity tolerance, water and nitrogen use efficiency, early vigor, cold and frost tolerance, pest and disease resistance. You name any of the problems and you will find, you Google and you will find some solution from the GM technologies. I'm here quoting this meta-analysis, a global meta-analysis of 147 studies, which was conducted. And it showed that GM technology adoption has increased crop yields by 22%, and farmers' profits by 68%, while reducing the use of chemical pesticides by 37%. So aren't these the aspects which we are trying to address when I said that what are the challenges? What do we need to do? So aren't these that the feeding the population, the crop yields have increased by using this technology. The farmer profits have increased by using these technologies. The sustainability of the environment is much better when you have reduced dependence on the chemical fertilizers, chemical pesticides. So GM crops can help. If you see here, these the proponents of sustainable agriculture, they say that we should adopt resource conservation technologies, RCTs. RCTs minimize on the inputs. So one of the resource conservation technologies is the no tillage or reduced tillage practices, and growing crops under water limited environments. If you see here, the adoption of the zero tillage can be possible by using the GM herbicide tolerant crops. Although, I think there are certain problems with this approach, but certainly for now, if you see that this adoption of zero tillage is possible because of the GM herbicide tolerant technology. If we have coupled this with nitrogen use efficient crops, then we reduce the inputs in terms of the chemical fertilizers, which get bio-leached, which get leached to the environment and cause pollution, cause eutrophication of the lakes, etc. So this will, the GM insect-resistant crops reduce farm operations. How do they reduce? Because then you have the less, less number of sprays to be given. When you use insect-resistant crops, they have an inbuilt resistance against these pests. So they minimize the input in terms of insecticide sprays. Thus, reduction in the fuel use and labor cost. It also decreases the labor cost as well as the fuel use problems. And this in turn lowers the carbon dioxide and nitrogen oxide emissions. So if you see that, Roundup Ready GM herbicide resistant soybean crops account for nearly 95% of no-till area in Argentina and United States. So because there are labor issues also involved with them, and they want to use this resource conservation technologies, they have adopted the Roundup Ready soybean crops. Here, if you see these are the graphs from an organization which is working in climate change. And if you notice that over a period of the last few years, the last century, there's a steep increase in carbon dioxide concentration. In the middle of the 19th century, it was around 270 microliter per liter. It is parts per million. And then if you see now, it is more than 400. And it is still going to increase. The similar is the trend with nitrogen oxides. So if you see again, why is it so? All this has a coincidence with high input chemical-based conventional agriculture. So in that sense, conventional agriculture has played a havoc with respect to the environmental aspects. So now, if we add GM crops to this system, then it reduces these emissions. The nitrogen use efficient GM rice and canola need less nitrogen fertilizer, thus decreasing the emissions of nitrous oxides, which is 300 times more potential cause of global warming than carbon dioxide. and it stays in the atmosphere for around 100 years. So we need to reduce these emissions. How do we reduce them? We can perhaps use the GM technologies. I have borrowed some of the ready slides available in this forum, ISAAA, which anybody can access, saving the time, and they have given us a consolidated picture of whole. So environmental sustainability, if you see the biotech crops, as I explained, less pesticide applications are there, and so they provide a better environment. They save, it saved 671 million kgs of active ingredients of pesticides in these 20 years. And 48.5 million kgs alone in 2016. Similarly, if you see here, had we not these crops, we would have to expand the area under agriculture. And that could not have been done without, causing problems to the forests, to our biodiversity. So in a way, by increasing productivity, by higher productivity, they have reduced the problems and helped to conserve biodiversity. If you see, 183 million hectares of land from plowing and cultivation got saved. It is a gain in terms of saving the environment. Yeah, with consumption of each liter of a tractor diesel, around 2.75 kgs of carbon dioxide would otherwise have got added into the atmosphere. So when you save on these farm operations by using these RCTs, we are able to save, and we are reducing the carbon dioxide emissions. And they have quantified, the Brooks and Barfoot has actually, the original paper, they have equated it to around 16.7 million cars. If we take it out from the roads, so this much of carbon dioxide has got saved from getting into the environment. Food and livelihood security. Again, as I told you, the biotech crops reduce food production costs. The meta study already discussed, I showed there. And if you see in terms of the increased yields, a US 186.1 billion farm income gains are there because of the biotech crops. And in India, they helped to elevate poverty and hunger and ensured better livelihood with higher yields. Around 17 million farmers and their families, which is around 65 million people, have benefited from this technology. Actually, there are so many people entering into this talk now. Yeah. So those people who oppose these technologies, for them, there is a question. Did we have some alternatives in these cases? This is the example of one of the farmers in India who grows cotton, the BT cotton. So if you see, the BT cotton technology attracted young farmers to cotton farming in the country, which is what I had raised a concern about. So 50% and higher the number of the surveyed farmers coming from the lower middle age group, 21 to 40 years, in Maharashtra, Andhra Pradesh, and Punjab. 95% occupied total cotton area is GM cotton, is BT cotton. So had this technology not been good, why would 95% of the area get covered? BT cotton is a scale neutral technology. That means it is accessible to all. Anybody can use it. The fears which are caused, which were caused earlier, the patent technologies and all that. So it is not a big problem. It is not a concern at all. The BT cotton contributed to the doubling of the cotton yield of the farm level in both irrigated as well as the rainfed conditions. If you see it in under rainfed conditions, earlier it was 4 to 5 quintals per hectare, now it is 8 to 10 quintals per hectare. And under irrigated conditions, the similar, 22 to 24 quintals per hectare productivity. In the states survived a substantial decrease in insecticide sprays and control of the American bollworm achieved. So 82% decrease in the chemical pesticide applications. Isn't it in the benefit of the environment? Isn't it going towards, tending towards the same objectives which the organic agriculture people have? Do they not want that, the chemical inputs to the environment should get minimized? Yes, do they? They do. So this 82.8% decrease, it tends towards that objective. And there is almost 99% reduction in the American bollworm. So if you see the profit reported by BT cotton farmers in all these states, it's also quite encouraging. It's more than 53,000 rupees per hectare for Punjab, around 40,000 for Andhra Pradesh, and around 32,000 for Maharashtra. So those critics who think that this has a problem, there are certain issues, do we have an alternative? The question to them is that we don't have. So next. So transgenics for organics, is this the way forward? If you see Norman Borlaug, he has way back, he told that the universal organic farming will only feed up to 4 billion people. And organic crops will require more land than GM crops. At this time, of course, it is a good technology, but is it with the same the genetic inputs which it takes right now, is it going to be able to feed the growing population? It's a big question. Organic products are not necessarily better for the environment. Some studies have shown that organic cereals, milk, meat generated more greenhouse gas emissions per product than their non-organic products. So, if you want to go into this, you can consult this paper also. Per unit product, organic produce generates higher nitrogen leaching, nitrous oxide emissions, ammonia emissions, eutrophication, and acidification potential than conventional methods. Again, here I would try to say that let it not be conventional agriculture versus organic agriculture. Let's try to find out solutions in the contemporary to the contemporary challenges from the technologies which are available to us. So here, if you see, the GM plants have not shown any additional detectable risks to environment or human health beyond the typical uncertainties of traditional plant breeding. This is the European Commission report 2001, based on research spanning 15 years and involving 81 projects with more than 400 scientists. Late blight resistant cisgenic potatoes. This is simply a gene for the late blight resistance. in these potatoes, wilt-resistant bananas, the golden bananas, golden rice. These are the examples, the candidate examples of these. This is a term which has been introduced as organic crops that could be acceptable to the farming, organic farming, because they enhance the nutritional qualities. They address the problems of the chemical inputs which are given to the agriculture. If can we grow such crops under organic conditions? We need to think. We need to think. So should therefore an unknown risk warrant overregulation, especially in the public sector R&D? There is a lot of regulation of the technologies, GM crops, and on what basis? Mostly it is the unknown risks. Here, this is a letter, the excerpts from a letter which the Nobel laureates, more than 100 Nobel laureates wrote it to Greenpeace. The laureates' letter supporting precision agriculture, GMOs, to the leaders of Greenpeace, the United Nations, and the governments around the world. So if you see here, they have delved deep into the concerns. And here I want to highlight one very important aspect, which is like a total of 1 to 2 million preventable deaths occur annually as a result of vitamin A deficiency. 1 to 2 million deaths. And the blindness, the causes, vitamin A deficiency causes blindness in children, and it is around 250,000 to 500,000 children per year who suffer from this problem. So, is it fair enough to oppose golden rice? There is no such thing added into that which would be harmful. So, the Nobel laureates conclude in their letter, how many poor people in the world must die before we consider this a crime against humanity? They have gone very strongly against those people who go against golden rice in particular, and GM technologies in general. Now, there is another aspect to this problem: the public and the private sector. Whose monopoly? Who gains out of all this, biopolitics? Collectively, there is no sufficient scientific data and arguments that should prompt political determination to develop GM crops in public sector. Else, excessively high costs of regulation would be a blessing in disguise for multinational agricultural companies to keep hold of the GM crop development. So, is it that we are doing a service or a disservice when we oppose? Actually, we are in a way helping the big multinational companies monopolize this sector. If you see here, the private companies, this M.S. Swaminathan, the first World Food Prize winner. He is the father of Green Revolution in India. He says that the private companies will obviously produce technologies where the small farmer will have to buy the seeds every year, and where the findings are protected by intellectual property rights. So this is to be kind of a practical way of looking at things, that these companies, these private companies will try to gain maximum economic benefits out of this. There is a very good expertise in our public sector institutions in the fields of molecular biology and genetic engineering, and we should derive full benefit from them. So he says that we must involve public sector more and more into this. That is how we address the second part of the issues which the 1998 declaration had raised, the social issues. So there is not simply one way of organic or conventional farming, as there will always be compromises to be made. Debate needs to go beyond organic versus conventional. And in my opinion, GM crops can stand in both. GM crops can help achieve those targets which are set by organic farming proponents. So they should be allowed. If, say, for example, some guy wants to grow GM rice in an organic way, why can't he sell it as an organic produce? Just because it has been manipulated at genetic level? That is kind of a problem addressing. So if you see the Nobel laureate Norman Borlaug, he says GMOs can play a very vital role in people's lives. However, this must be accompanied by political goodwill, because technology alone cannot survive without decisive support. This is none other than the Nobel Peace Prize person, the father of Green Revolution, founder of the World Food Prize, and the founding patron of ISAA. I think with this, I thank you all for patiently listening to me, and I would welcome if there are any particular queries and questions. Thank you.
Hello. People flee from agriculture to services sector. So we need to ensure their livelihood security if we are sincere about development and resource conservation. We can use many options like agricultural automation, high yielding seeds, organic farming. And this way we can redefine agriculture. And in all this, biotechnology holds a promise. That was Dr. Amjad Masood Hossaini. Thank you, sir, for such a beautiful and such a thought-provoking talk. Before we move further towards the technical session, towards the participant presentations, so there are a few questions from the participant side for you. And we would like to listen to those questions and answers. So number one question from a participant is that, how can modern profit-driven agricultural biotechnology meet the basic needs of the poor? This is one of the questions.
Profit-driven agriculture for poor. In the last slide, if you see, this is the very pertinent question, which Professor Swaminathan tries to answer. He says that if we go on, opposing the GM technologies, the regulatory costs which are put are unbearable to the public sector institutions. It is not easy for them. So who gets benefited? All these multinational companies get benefited out of that opposition. So in a way, if this profit-driven agriculture is to be made useful for common people, you have to encourage the public sector involvement in production of these high-yielding, remunerative, sustainable crops. You have to unmute yourself. Sorry, you have to unmute.
Thank you for the answer. So another question for you is biotechnology opening a new window of greater biodiversity, or it's actually reducing it?
Sorry?
Is biotechnology opening a new window for greater biodiversity, or it's actually reducing it?
Mm-hmm. Look, if you see at the commercial agriculture Commercial agriculture needs to be, sustainable. So in that sustainability problem, we discussed the use of the chemical based input agriculture. Now, if we move to the other aspect of it, if we move to the other extreme, that is the organics, in that case, we have to expand the area under cultivation of the crops. If we increase the area under cultivation, that means we are going to clear more of the forests, more of those areas which are the common resource of whole humanity. So in a way, if you clear forests for agricultural purposes, then you are going to reduce biodiversity. So if your high yielding GM crops, on the one hand, they minimize the input of chemical based agricultural inputs, and on the other hand, they address this problem also by increasing productivity and without having to clear more of the land for agriculture purposes. So it is actually increasing, helping conserve. I would not say increasing, I would say helping conserve the biodiversity. And if you see from the genetic aspects, genetic way of looking at it, if you add a variety, you are actually increasing agricultural diversity, agricultural biodiversity. So you are increasing one more crop, so you are increasing biodiversity, agriculture.
Okay, means it is going towards the increase in diversity. So another question is, what are the policy issues for widespread adoption of GM crops?
Again, if you see in the last slide, Norman Borlaug, he says that it is not the scientific evidence only which is important. It is the political will which is important. And political will is governed by many aspects, many things. There are pressure groups, the common people, how common people perceive things. So there has to be change in the perception of the common people. And that perception can be changed only through, the conferences like these, wherein you are discussing these aspects. And we are delving deep onto the issues wherein people get a general idea that, okay, is it really that 100 plus Nobel laureates have signed a thing which they believe that it is true? And what actually is preventing this technology from, seeing the light of the day? Although it is very popular in the West, in the US, United States, and many other countries as well, but still, the opposition is basically on unknown risks. So the unknown risks, when you call somebody it is unknown, it is really a dread something. And the fear, there is a saying in a philosopher, by a philosopher, that you can address a problem, you can address a disease, but you cannot address a fear. It is very difficult to address that. So you have to address here the fear, and that fear can be addressed only through a dialogue, a fair dialogue, an open dialogue between the society and the scientists and the proponents.
Thank you, sir. So dialogue is the key here. So another question goes like, how far biotechnology has been successful for developing aerobic rice varieties for reducing the water footprints of rice cultivation?
Aerobic rice is actually, the highland rice, wherein you have limited access to water. So by and large, if you see that drought conditions, aerobic rice minimizes the input of water. So in terms of the climate change, in terms of the input of water, you have a lot of available resources which address the issue of water use. So if you have water use efficient varieties, you save on water, and that makes arable rice a viable option for those areas where the irrigated conditions are not there. You must remember that arable rice does not compete with the irrigated rice. It is an option for an area where you don't have anything. You don't have, it is something to nothing. Comparison is for something to nothing. So the GM technologies, as they address the condition, the problems of the drought, the problems of cold, heat, stress, all these, similarly, they address this issue also.
Thank you. So one last question.
Sure.
Does organic agriculture and agricultural biotechnology have the potential to bring second green revolution, particularly in areas with constraints like soil salinity, water scarcity, and uneven monsoon rains?
Yes. Uh, it is a very good way of putting, and this is the crux of the talk. This is actually, I propose that instead of going having a dichotomy, organic agricultural biotechnology, it has to come together, the diverse technologies of organics and the high precision molecular techniques involving engineering of genomes, engineering of the plants with traits for the current century. They need to come together, and then only we can address the aspect of the sustainability of agriculture as well as the sustainability of the whole human population. Under the climatic change conditions, which he has, say for example, I told you in the beginning that climate change has two aspects to it. One is the aspect of mitigation. Mitigation aspect, you cannot change because GM you are using, so you will not have a dramatic effect on the thing that now we will have a monsoon which is right on time. No, it won't be like that. The other aspect to it is resilience, building the food production system which is resilient to climate change. So even if you have an inconsistent monsoon, still your crop should be able to survive in those in that period wherein there is a lot of stress. So if you see here in Kashmir also, there are many aspects in agriculture wherein we have got delayed harvesting. Sometimes we have late rainfalls. So the crop has to survive that period which causes stress. It has to. There is no other option. The option is that it can address it through building a resilient system. And that resilient system can be created through use of these high precision gene manipulation based technologies, which now have advanced to CRISPR-Cas, TALEN, cisgenics, all these. But still, the problems are with respect to the acceptability, the regulation, the biopolitics of the crops.
Thank you, Dr. Amjad. Thank you for an insightful talk. It was really beautiful that you deliberated upon all the aspects of biotechnology and organics with so clarity that there's honestly no doubt. And the questions you answered was very beautiful. I thank you again. Thank you very much for the talk.
Thank you. Thank you so much.